Hello there, Shark Boy and Lava Girls here to talk to you about how volcanoes are formed. So, how exactly are volcanoes formed? Well, volcanoes originate from something called plate tectonics. Plate tectonics refers to the movement of the Earth's crust, causing the continents to move. Plates at our planet's surface move because of the heat in the Earth's core that causes molten rock in the mantle layer to move. It moves in a pattern called a convection cell that forms when warm material rises, cools, and eventually sinks down. There are three types of plate tectonic movements, the first being convergent, which is where plates come together and collide. The second being divergent, which is where plates go in the opposite direction. And transform plate movements, where plates slide past each other in a lateral sliding motion. Divergent plate tectonics are the ones who give us our underwater volcanoes. These underwater volcanoes are actually 75% of annual magma output. Convergent plate tectonics give us our terrestrial volcanoes, which are the ones above land. Here's a video further explaining plate tectonics.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other. As the edge of the sea floor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide.
Now, where do volcanoes come into all this plate movement? Deep inside Earth, between the molten iron core and the thin crust, at the surface, there is a solid body of rock called the mantle. When rock from the mantle melts, moves towards the surface through the crust, and releases pent-up gases, volcanoes erupt. Extremely high temperature and pressure cause the rock to melt and become liquid rock or magma. When a large body of magma has formed, it rises through the denser rock layers toward Earth's surface, between the ridges and trenches. Volcanoes are actually the vents in which this rising magma can escape. Here's a video further explaining the eruption of a volcano. Now, can we find any of these insane things we call volcanoes near you? These are primarily the areas where volcanoes are present. There's a large concentration to the west coast of North America and South America due to plate tectonics. Notice The area where a large number of earthquakes and volcanic eruptions occur is in the basin of the Pacific Ocean. This is what we call the Ring of Fire. In a 40,000 kilometer horseshoe shape, it is associated with a nearly continuous series of oceanic trenches and volcanic arcs. It has 452 volcanoes and is home to over 75% of the world's active and dormant volcanoes. Keep up with our Twitter page and look out for our next video explaining how to protect yourself from a volcano.
Created using Powtoon.